This is the remote control car that I created using Raspberry Pi 4. It was fun and I also learned a few things. It is very easy to assemble, so if you already have a Raspberry Pi lying around, then you can build a RC car. If you are someone who doesn't have Raspberry Pi but you want to build a RC car, then you can look into Arduino, as it is better suited for hardware projects. But then again, Raspberry Pi is capable of doing more stuff as it is a general purpose computer. I will provide the links of the components in the description, and the Python code is already available on GitHub, and its link is also available in the description. So let's get started. These are the components that we will require to assemble our Raspberry Pi car. The first component is a popular 18650 battery. It's a 2500 mAh 3.7 volt battery which when fully charged provides a voltage of 4.1 volt. We will be using two of them together connected in series so that the combined voltage will be around 7.4 volt and the combined capacity will be around 5000 mAh, which should be enough to power all of the components for some amount of time. Next, we have two acrylic sheets which will make the main chassis of our car, and we will place the components on them. Then we have four 200 rpm BO motors and a set of 4 wheels, some brass standoffs, some M3 screws and nuts. Then we have two motor controllers. These are L298N motor drivers. Using two of them, we can control each of the 4 wheels in both the directions. Next, we have main Raspberry Pi 4 board. I have already installed Ubuntu server on it. The board will be powered by a step-down power supply module. This module converts the input of any voltage between 6 volt to 24 volt into an output of 5 volt 3 ampere, which is exactly what we need to run the Raspberry Pi. We will be directly connecting this to our battery pack, and this will in turn power our Raspberry Pi. The power supply has a USB Type A interface, so we need a Type A to Type C USB cable. Then we have a battery holder, a Raspberry Pi case, a voltage indicator, few jumper wires, and I have connected them together to make a bunch, which we will connect to the GPIO pins of the Raspberry Pi. One thing to notice is that we have to power at least 4 devices, starting with the step-down converter, 2 motor controllers, and a voltage indicator. So I have soldered 5 pairs of jumper wires to the battery output. Connecting them individually creates a mess of wires, and this way we can easily connect and disconnect the components. So let's assemble. We are going to first install the brass standoffs, which will give rigidness to the chassis. I have extended the length of the standoffs by adding an additional spacer in order to increase the height so that I can fit the motor controllers inside the chassis itself and keep the batteries and Raspberry Pi on the top. We will be keeping the screw side of the standoffs on the top and nut side on the bottom, as I find it easier this way. Now that we have installed all standoffs, we will now install the motors. I have already soldered the wires on the motor to make the connection stable and secure. I have also put some solder on the ends of the wire. This is called tinning. This way it's easier to make the connection. To install the motor, we will first insert a plastic holder in one of the slots of the acrylic sheet and keep the another holder on the edge of the sheet and install the motor in between them using nuts and bolts. Now that we have installed all 4 motors, we will now attach the wheels. It's very easy, we just need to align the shaft design with the cutout inside the wheel. So now that our motors and wheels are connected, we have to connect the motor controller. So as you can see, these are the motor controllers. I have added some extra spacers so that I can install them on the chassis, and here you can see these are the inputs. So ground, 5 volt and 12 volt. Okay, and these are the two outputs. Two output here, two outputs there. Out 1, out 2, out 3, out 4. Okay, 4 outputs are there. So we can either control 4 motors with one controller in one direction, or we can control one motor in 2 direction with these two. So we can control 2 motors in 2 direction either way. Okay. So I have this screw, and I will just turn it over so that I can properly install it. So too little off center, but that is fine with me, and even if it may not break. All other 4 are just to keep it aligned. They are not connected, but they will keep it that aligned. Okay. So now it is installed here. So it is connected. So we will be connecting to 12 volt. Okay. So our power supply is connected. Similarly, we will do it for this also. We will connect 12 volt with this 12 volt with this. Now we will connect it there, but for the timing we will just test with these two motors first, so that if there is some problem we can change. So I am using my battery holder. I will connect my batteries with them. Okay. I will connect my ground to ground, and power to power. Okay, I will turn my battery on, and we can see there is a light here. You can see it is illuminated, right? We have not set up our Raspberry Pi here, so we will test them later. And one more thing, that we need not keep them in any particular order. We can connect them in these wires in any order. We can configure using software which pins we want to fire. So let us turn it off, and we will disconnect the battery. Now we will connect the wires from the motor to the motor controller. Similarly, we will do the same for this also. Okay, so this is done. Now we can place it here. We need to work on the top, so we will connect a battery box there. That's very fine. So let's keep it aside. You can see I already have installed 2 placeholders. So this holder is fit. Now I will try to mount this Raspberry Pi So my Raspberry Pi is mounted here, and I will mount this is also study. I have this Type-C cable. So this Type-C cable will connect here. Using the Pi. And hold it in place. That's all. Yes, so I've connected Raspberry Pi in power supply using battery. So these connections should be from the inside and not from the outside. So I will just disconnect them. And I will move on this bunch of wires using this bigger one. It will come on top of this like this. These two are power and these four are for motor. So let's just tie them together so that the don't get entangled. So these two are now connected here, and others are free. Let's give input to this motor controller. So black to black, red to red. Similarly for this also, we will connect black to black and red to red. So now we are giving power to our motor controller and Raspberry Pi also, but that is not enough. So we need to connect these four wires. So two here, two here, two here, two here. So total four here, four here. Total 8 wires we need to connect this with the Raspberry Pi. So I've already created a bunch of wires. So these four are connected, and we will use this four. Take them out. Similarly, another 4 bunch that we will connect on this side. So you can see we connected all 4 here and all 4 here, and this also we will take off using these bigger one. So now our wiring is done. Some 4 are left. That we will take out some again. So the moment of truth has come. We just need to connect these wires with the Raspberry Pi. Other than that, everything looks fine. We need to connect this voltage display also. This is totally optional since I have it. So I'm connecting. And for the time being, you can just keep it lying like this. So now you can see it is fitted perfectly. Now let's see. So let's turn it on. So one motor controller, both motor controllers are turned on, right? And our Raspberry Pi is also on, and then we can see the voltage status here. So everything looks fine. So now what we need to do, we need to work on the programming part so that this hardware works. We will connect these wires. So now we need to connect our motor controller input pins with the GPIO pins on this Raspberry Pi. I am using GPIO pins 2009, 10, 11, 12, 16, 17, 13 and 18. and these correspond to in pin number 21, 19, 23, 22, 36, 11, 33, 12. 20, 21. Okay. So I have connected these wires like that. Okay. So now we need to test which wheel corresponds to which GPIO pin, and I have written a small program in which I am using only the first variable, which is forward. We will run the forward function for 3 seconds and check which wheel moves in which direction. We can mark this side as front and the other side as back. We will be using GPIO pin 9 here. The code is available on GitHub and I will share the link in the description. So this is my back wheel which is moving in this direction, which if it is like this, right, until ahead so that you don't have to. So I'm going to see, and this is my back wheel, left wheel which is moving forward. Okay, so I know 9 is back, using 10. So let's do it here. This is a brute force way of doing it. So what is moving forward? My back right wheel is moving forward. So we'll go to another file already created. So for this I have like created 4 functions, 4 motors. So I'll just left, so front left motor, by which pin does not. So front left motor, my pin is 16. Come on to make it worse. Pin is 17. The rest of the file is just like that, and this is the code. Okay, set it, save it, edit it, and do try to control. Now to move forward, all wheels should move forward. Yes, they are all moving forward. Now to move left hand. So these two are moving back and these two are moving forward. Right hand. Okay, so let's try it. So let's try to make it reverse. It is a fine.